Hello.
Hello.
Hi.
Good evening, it's Jose. Hello? Hello?
Hello.
Yes, I'm Jose. Nice to meet everybody. I'm new today
Hello.
to the trainer.
Hi friends. Krishna here. Yeah, can you please confirm me? Are you
Hello.
able to hear me?
Yes, I can hear you.
Okay, great.
Krishna, your voice is low. I cannot hear proper.
One second. Yeah. Okay. How about now? I think now it's clear, right?
Yeah,
Okay.
now it's
Okay,
clear.
that's better.
Thank you, friends. Okay.
That's much
So
louder.
in last class, yeah, let's start the section. So yesterday we completed introduction to the Hadoop, like what is Hadoop, what is advantage Hadoop, those concepts completed up to last class. How architecture is working, those concepts completed last class, right? So let me ask a question before going to start the today's section. You have the chat box is there. You can give me a reply through chat box also. Okay. How Hadoop is possible to store big data? What is the advantage of what concept is there in Hadoop to store big data?
Sorry, can you record the meeting? The organizer record?
Yes, recording is going on.
Okay, because it says still record. Doesn't say record.
No, already recording is there. Is the first class for you, Joseph? Jos?
Yes. I'm new today from Nirvana.
Oh, okay.
And yeah, also myself Ram, and I'm also it's my first class today.
Okay, great. No issue. Just continue. This is second class. Yesterday only we started. Yesterday I gave the just introduction terminology, like what is Hadoop and everything. Please continue the section today. You get the clarity. No issue. Okay.
Okay.
And also stay here after the class. Also, just I will take this just 50 minutes, 20 minutes backup after the class. Today's class. Okay. So the question is. Okay. Let me ask you a few questions of yesterday's class. Then we'll continue the today's class. So, what concepts are available in Hadoop to store big data? How Hadoop is possible to store big data? Mm-hmm. Okay, I got one reply. Great. Yeah, that is the answer. I hope my question is clear. Hadoop is possible to store big data. But question is, how it is possible? What concept is there? Good, Taro? Yeah, that is the answer. Yes, Mahmoud. Yes, great. Yeah. The answer is Hadoop following a feature called distributing storage system feature. Very good. Because of this feature only, Hadoop have capability to store big data. So what are the demands taking the responsibility in Hadoop to store the data? One more question. So in Hadoop, yeah, see the architecture. This is my Hadoop architecture. So what is the demands taking the responsibility to store the data? Understand question is important. I hope my question is clear. Great. Yes, Ruchi. Yeah, that is the answer. Okay, I'm not getting your question. Yeah, my question is, what are the daemons taking the responsibility to store the data in Hadoop internally? There are 5 types of in architecture. There are 5 types of daemons is there. Which daemons is taking the responsibility? Good, Taro? Yes, that is the answer. Okay. Hopefully everyone replied. Yeah. Very good. Yeah, that is the answers. So very good. Thank you. Name node and date node taking the responsibility to store the data. Name node and date node taking the responsibility to store the data, and job tracker and task tracker taking the responsibility to store the data, so to process the data. Sorry, yeah. Name node and date node to store the data, job tracker and task tracker to process the data, secondary name node, backup of a primary name node. Okay. Now the point is, just I'm repeating last class. Hadoop very much suitable for what is advantage Hadoop? What is the main advantage Hadoop? Yes, Hadoop is possible to store big data. First thing, Hadoop possible to store big data, and also by using Hadoop you can store any type of data, and also we can process big data also in less time. 3 advantages. The first advantage, we can store any volume of data, no matter terabytes, petabytes, any volume of data also can easily store it. Second advantage, we can store any type of data also, like structured data or unstructured data, semi-structured data, any type of data also you can easily store into Hadoop. And third advantage, yes, by using Hadoop, we process big data also in less time. We process big data also in less time. Like I have 10 terabytes is there in my storage system. The 10 terabytes I need to process. Compared to other storage systems, Hadoop gives you better performance. Okay. So in last class, we completed how architecture is working internally. How architecture is working internally. That concept completed up to last class. Again, tomorrow, again I'm repeating, like first class and second class, just like introduction classes. And tomorrow onwards, actual classes started. In tomorrow's class, again I will repeat you with the complete in details, like how exactly the roles and responsibilities of the name node, data nodes, how internally working step by step. I will give you with the practicals tomorrow onwards. Okay, but yesterday just completed a high level discussion. And now coming to today's class, yes, today's class also just like terminology introduction class, like yesterday how internally Hadoop is working, that concept completed. And today, as a developer, what is our responsibility? What is our responsibility? What we are doing in Hadoop every day? Okay, so those concepts I am going to explain you today. And what, just see friends, yeah, these are the ecosystems are available in Hadoop. These are the tools, namely Hive, Pig, Scoop, HBase, MapReducing, Flume, Oozie, Zookeeper, like this. These are the tools are available in Hadoop. These are the tools are available in Hadoop. By using these tools, as a developer, I am going to write a queries. I am going to create a jobs. Okay, by using these tools, I'm going to analyze the data. By using these tools, I'm going to analyze the data. So what are the tools that are available? These are the tools. Today, I'm giving you the high-level information, high-level definitions about all these ecosystems. And tomorrow onwards, we are going to discuss all these concepts with the practicals. Okay? Okay. So before going to start the section, again, let me discuss about the architecture. So in our Hadoop architecture, we have name node is there, secondary name node is there, HFS client is there, data nodes is there, and task trackers are there. Equal number of data nodes, equal number of task trackers are available, right? And also, we have flexibility to add extra data nodes also. We have flexibility to add extra data nodes. There is no limit to adding extra data nodes. I can add 5 data nodes, 10 data nodes, 100 data nodes, 1000 data nodes, whatever it is. But equal number of data nodes, equal number of task trackers are available. Equal number of data nodes, equal number of task trackers are available. Okay, but only one name node, one secondary name node, one HFS client only is there. Okay, so let's go for some administration discussion. Yes, what is architecture is there? This architecture I need to configure. What is architecture is there? That architecture I need to configure. Wait, I will tell you each and every point. Sure, Ram? Yeah. Don't worry. I will tell you what are the points is everything. I will repeat you. So this is our architecture, and this architecture I need to configure. How can I configure this cluster, this architecture? Yes. What are the Hadoop architecture is there? That architecture we can configure into 3 modes. We can configure into 3 modes, namely local mode, standalone mode, pseudo distributed mode. These are the 3 modes are available in Hadoop cluster. We can configure that Hadoop cluster into these 3 modes. Let's see third one first, pseudo distributed mode. What is this pseudo distributed mode? Yes, this is the perfect cluster example in our production. In real time, yes, this is the cluster only we are using. In this pseudo distributed mode cluster, we have name node, secondary name node, HFS client, job tracker, data nodes, equal number of data nodes, equal number of task trackers are available. Equal number of data nodes, equal number of task trackers are available. There is no limit for data nodes. If we want, we can add extra data nodes also. Depends on the size of the data. You can decide it. We can add the number extra data nodes also. But only condition is if we add extra data node, yes, we need to add extra task tracker as well. We need to add extra task tracker as well. Okay, so in production, in real time, we are using this cluster only. The cluster name called pseudo distributed mode cluster. Okay, then what is the drawback of this pseudo distributed mode cluster? This is a cluster I need to install into my laptop. Is it possible? No, because required more than one data node. That means more than one laptop is required. It's not possible. But I want to practice. How can I? What is the solution? Solution is there. That is called standalone mode. Standalone mode. I can install the cluster into my machine also. Standalone mode. In this standalone mode also we have name node is there, secondary name node is there, HFS client is there, but only one data node and one task tracker only. There is no multiple data nodes. Only one data node and one task tracker only is there. If it is more than one data node, terminology changed. If it is more than one data node, we are calling like a pseudo distributed mode. Only one data node, we are calling a standalone mode. The standalone mode, it's easy to configure into our laptop. Everything, name node, secondary name node, HFS client or job tracker, data node and task tracker. One data node, one task tracker. It will be configured into one mission only. It will be configured into the one mission only. That is called standalone mode. The difference between second one and third one is only one thing. That is number of data nodes. If more than one data node, pseudo distributed mode. Only one data node, standalone mode. Okay. And coming to the first one. Yes, the first one we are calling like a local mode. The local mode also similar like a standalone mode only. See friends, terminology is important. So local mode also similar like a standalone mode only. Even local mode also we have name node, secondary name node, HFS client or job tracker, one data node and one task tracker is available. But the difference between first one and second one is, okay, the second one we need to download the jar files. The second one we need to configure manually. Even third one also. Second one, third one, both are. Yes, we need to configure the cluster. We need to configure the cluster. We need to download the jar files. And yesterday we discussed like the block size, the replication number, everything we need to configure second one, third one manually. As administrator, we need to configure second one, third one. But I am a developer. I don't know admin concepts. How can I practice? Solution is there. That is called local mode software. The local mode software already configured image file. Yes, as a developer, just I'm downloading the jar file. Installing that jar file into the Hadoop cluster. Just downloading the jar file and installing that jar file into my laptop. That's it. That is called local mode software. Okay. So in this local mode software, not required to configure anything, not required to do any installation. Even in Hadoop, number of ecosystems is there. All these ecosystems also already installed. All these ecosystems are already installed in this local mode. Clear? Any queries? Okay. So no queries. Great. Everyone is clear, right? Yeah, friends. If you have any queries also, let me know so that I will repeat the concept also. And in going forward, I will help you friends to install local mode as well as standalone pseudo distributed mode also. I will send you the software today after the class. Just to go for the download, I will help you to install. Most probably, day after tomorrow class, we have the installation.
Krishna, this is Naveen.
Yes, Naveen.
Hey, I had a question. Now, when we create this Hadoop cluster, right, we have this name node and we have this data nodes. Now, you said like each data node would be a separate processor and a separate machine. I mean, how does it work? So you have like name node in a separate machine and you have each data node acting as its own machine?
Exactly. All are separate data nodes. Data nodes are separate servers. But we have connection is there. My connection, yes, Muhammad also that one. Yes, SH, like I said, crucial mechanism configurations is there. We are making a connection so that everything in one line. What are the daemons are there in my screen? Yes, all are configured.
So each one is a separate server. Like for example, I mean in general in production in WebSphere, when we say a cluster, it is nothing but collection of servers, right? So basically, you have the name node in a separate server, and you have each data node in a separate server. And the name node is the one which basically determines where to send the data or whatever it is. I mean, right?
Exactly.
Okay.
So here, even if I want to add extra data node, for example, right now in my cluster, 5 data nodes is there. Tomorrow I need to add 6th data node. Yes, we need to give that information to the name node.
Right, but the data node, when you say data node, it is a hardware. It is not like just, right?
Exactly. It's like see the terminology like a daemon. What is the meaning of the daemon? Like a missions. There are 5 types of hardwares. All these 5 we call it one cluster.
Right, but daemon is nothing but a background process. So we can't imagine that each data node will act like a different thread, right? Each data node is once again has its own different processing mechanism. It has its own processor. It has its own hardware.
But all are working under the name node.
Yeah. I mean that is the gatekeeper exactly. It determines what to do and what not to do, which data node to access and all. But when we say a data node, it is nothing but not just like a thread running on the background, but it is something like a proper hardware.
Exactly. Very good. And tomorrow class again I will go for in detail about these concepts so that you get more clarity. Because in the first class we completed a high level discussion only. We are not in detailed discussion about the architecture. So we get a more clarity. I will give you diagrammatical explanation also so that you get more clarity. How the name node and data node communicated, what exactly the responsibilities and everything, you get the clarity. As of now, yes, what you guys are understanding, yeah, that is more than enough, high level. Okay. Great. Any more queries, friends? Can I move to the next one?
Yes, no problem.
Great. Thank you. Thanks for confirmation. Let's moving on. HDFS. And what is the meaning of HDFS? The term indicates Hadoop distributed file system. HDFS means Hadoop distributed file system. So in Hadoop, there are number of data nodes is there. There are number of data nodes is there. All data node space we call HDFS. All data node space we call HDFS. Okay, the meaning of HDFS is like, for example, internally I have multiple data nodes is there. Yes, as for discussion, each and every data node they have their own space. Like this, 2 data nodes or 3 data nodes, 4, 5, 6, like this. There are a number of data nodes is there, but all data node space we call HDFS. So the meaning of HDFS is the terminology. For example, like in my computer, I'm calling like C drive, D drive, E drive, like this. Drives is different. Okay, but all drive space I call like a hard disk. My laptop hard disk, right? Similarly, all hardwares, all data nodes space we call HDFS. And tomorrow, my manager asking, Krishna, yes, is asking like this. Krishna, can you please copy sales file into the hard HDFS? That's it. He's telling only. So that means what he's telling is copy some sales files. Sales files is there. Copy the sales files into Hadoop HDFS. That's it. He's not telling copy sales file into data node 3 or copy data node into data node 2 or 6. He's not telling like that. He's only telling copy sales file into HDFS. That's it. So if, for example, the sales file is available in data node 6, I'm logging data node 2. I'm logging date node 2. Is it possible to access this sales file? Yes, possibility is there. That possibility is there. That is the logic here. Complete space, all hardwares, like all date node space, we call it HDFS. I can log in through date node 1, but the file is there, date node 3. Yes, I have the access. Completely one space. And tomorrow, I'm copying one more file. For example, tomorrow, I'm copying sales file, sales 2. Into date node 3. Yeah, possibility is there. Name node and date nodes will take care that file where I need to store. Internally, those two will take care. But as a front-end user, I'm logging date node 3 or date node 1, some other way, whatever it is. I have the access. I have the access all files in HDFS. Okay. So clearly, HDFS means terminology. The complete space in Hadoop we call HDFS, Hadoop Distributed File System. The complete space of the Hadoop we call HDFS, Hadoop Distributed File System. Now the concept is, yes, in my Hadoop I stored yes couple of files. Sales file I stored, some sales files I copied into HDFS. Now my manager asking, yes Krishna, can you please give me some reports about the sales file? That is what he is asking. As a developer, what is my responsibility? Yes, I already copied sales file into HDFS. File copying successfully completed. Now he is asking, he wants some reports about the sales file. Yes, in Hadoop, number of tools are available. Namely, Hive, Pig, Scoop, HBase, MapReduce, Flume, Oozie, Zookeeper. Like this, there are number of tools are available in Hadoop. By using these tools, ecosystems, by using these ecosystems, we are going to analyze the data. By using these ecosystems, we are going to process the data. Now, today's class, I'm going to give you high-level definition about all these ecosystems. I will give you the definitions of all these ecosystems information. Okay. So again, tomorrow onwards, we are going to spend each and every ecosystem 5 to 6 days, at least 3 to 4 days. And that time we are going to discuss. For example, Hive is there. It's like almost like 5 to 6 classes. We discuss in detail about Hive with the practical. Similar to Pig also. Every ecosystem. But today's class, my intention, everyone want to know the terminology. So the first one is the Hive. What is Hive? Hive, it's one of the ecosystem in Hadoop. By using Hive, we are going to create warehouse environment in our Hadoop. By using Hive, we are going to create warehouse environment in Hadoop. It's like a data warehouse language in our Hadoop. Similar like MySQL, how we are going to working on MySQL, the same way by using Hive also in our Hadoop, we are going to work on it. By using Hive, we are going to create a table. By using Hive, we are going to create a table. After that, we are copying the sales file into the table. So the meaning of data warehouse is like our warehouse environment, how we are going to work on it. Like we are creating the tables, loading the data. That is the meaning of data warehouse. The same thing, Hadoop is a file system. Hadoop is a file storage system. In this file storage system, we are creating tables by using Hive. We are clearing the data by using Hive. example, I have some unstructured data is there. I have some semi-structured data is there. Those data I need to load into the tables. By using Hive, I am going to clean the data. By using Hive, I am going to clean the data. After cleaning completed, I am loading the data into the Hive tables. Hive tables. So simply, I am creating warehouse environment. Simply creating warehouse environment. So warehouse environment means like that, tables, applying the queries in my similar like MySQL. Almost 70 to 80% of concepts are similar to MySQL and HQL. Hive. Hive and MySQL both are similar. Almost queries and everything similar. Even syntax also. Look at here. Create table, table name. Both are similar. Even MySQL also same syntax. Here also same syntax. Okay. So I'm giving the overview, friends. Depends here again. So the question is, we can't process unstructured data in Hive, right? No, possibility is there. We can do it. Okay, different log files. There are different options is there. By those options, we can process. We can convert. We can clean. So before we need to process unstructured data, we need to clean the data. Once cleaning completed, then we can process. Directly is not possible. That is the reason we are cleaning the data. After cleaning completed, we are going to process the data. Okay. So Hadoop have capability to store different types of unstructured data, semi-structured data. First, we are cleaning the data. Once the cleaning completed, then we are storing into our Hive tables. Okay. I am giving the overview, friends, regarding Hive. And in tomorrow's class, regular classes, I will give you clearly, like with practicals, how to clean the data, how to clean unstructured data, how to clean semi-structured data. After cleaning completed, how to load those data, how to load the data into the Hive tables. Those concepts we are going to discuss regular classes. Okay. I get one more question. Is cleaning basically putting the data together? See, cleaning means like what is the unreadable format? That data we are converting into some readable format. That is the meaning of cleaning. Okay, unreadable format data into the converting into the readable format.
What does HQL stand for?
HQL stands for Hive Query Language. Okay, SQL means Structured Query Language.
Okay.
Similar like HQL, Hive Query Language. So I'm giving the overview. So it's one of the tool. By using this tool, basically we are going to analyze the data. We are going to process the data. Okay. And practicals time, I will tell you how it is possible. With the practicals, I will give you the regular sections. Now coming to the next one, pig. What is pig? Okay, before pig, I got one more question based on Hive. Can we relate to clearing to the transform phase of ETL? Yes. Point is, how to create ETLs in Hadoop, ETL approach. Yes, by using Hive and pig, these are the tools. Yes, we can create ETL operations, extract, transform, and load operations. Okay, so what is pig? Yes, pig also one of the ecosystem in Hadoop. Similar to Hive, by using pig also, we are going to process the data. By using pig also, we are going to analyze the data. Okay, but the difference is, depends on the data. Some type of requirements, Hive give the better performance. Some type of requirements, pig give the better performance. And pig is a scripting language. Pig is a scripting language in Hadoop. What do you mean by scripting language? Similar like Java is also one of the scripting language. Java is one of the scripting language. Similar to Pig also one of the scripting language. Okay, the Pig almost similar. Even the Pig also similar to MySQL. In MySQL, okay, what are the concepts are there? In Pig also the same concepts. Okay, depends on the requirement. Either we choose Hive or Pig to analyze the data. The both are same purpose. Okay, to process the data or to analyze the data we are using in our Hadoop. Okay, but only question is these two ecosystems, which one we are using? Which one we are using? Yes, that purely depends on the requirement and also the data. A simple example. For example, I have test processing is there. Test processing. I want to do test processing, especially for test processing, test analytics compared to Hive, Pig give the better performance. Pig give the better performance. If I want to store the data, if I want to maintain the data, clean the data, that time compared to Pig, Hive give the better performance. If I want to store or clean, that time Hive give the better performance. If I want to test processing, test mining, that time Pig give the better performance. Okay, and also by using Pig, we're creating our own functions and we are going to analyze the data. So simply, okay, I'm giving the overview. Like it's similar like a Hive. It is also one of the ecosystem, friends. It depends on the requirement. Sometimes we choose a Hive, and sometimes we choose a Pig to process the data. Depends on the requirement. Depends on the use case. Our data, we decided like which tool we need to use. Once we are entering the practicals, so that you get the clarity in what time we are using Hive and which time we are using Pig, you get the clarity. Okay, any queries? Yes, I got one query. What is text mining, text processing? Yeah, Mohammed. See, I will tell you this one with the practical time. Okay, generally I have some data is there. That data I need to process and I need to analyze. Okay, that time that is called we need like a text mining. But if I go for practical, then only get a more clarity. What exactly meaning of text mining, text processing? As of now, just remember the terminology. I am only expecting of today's class. Everyone want to know the terminology. If you know the terminology, it's very easy to learn actual concepts. That is the reason. Just I'm telling high level. I hope it's clear, high level. Can I move to the next one? Okay, thank you, Mohammed. Okay, thank you, everyone. The next one is Sqoop. What is Sqoop? It is also one of the ecosystem in Hadoop. By using Sqoop, we are going to import structured warehouse source system into the Hadoop. We are going to import the data between structured warehouse servers into Hadoop. Like what do you mean by warehouse? RDBMS. We are going to import the data from RDBMS to Hadoop. Also, we are going to export the data from Hadoop to RDBMS servers. Nowadays, most of the data we are storing in RDBMS only. Most of the data we stored in RDBMS servers only. That data I need to process. Okay, that data I need to analyze. In our warehouse servers, it's difficult to store the data. It's difficult to process the data. So that is the reason we are importing that RDBMS servers data into Hadoop. How can I import? Look at the diagram. As this is my SQL, one of the RDBMS server. The SQL, from SQL to Hadoop, I need to copy the data. And Hadoop to SQL, I need to copy the data. Sqoop is the tool in Hadoop, just like a transporter. By using Sqoop, we are not doing any analytics. Like a transporter, what we are doing? Just we are transporting the data, right? Transporting, right? Similarly, in Hadoop also, by using Sqoop, just we are transporting. We're transferring the data. Once we are copying and placing it to the Hadoop. Once data placing completed, then by using Hive and Pig, we are going to analyze the data. Okay, just like a transporter. That's it. Okay. So and next one. Flume. What is Flume? Same like a scoop. Flume also one of the transporter in Hadoop. By using Flume also, we are going to import streaming data. We are going to import streaming data. What do you mean by streaming data? First question. What is the meaning of streaming data? Any guess? I got one reply from Mohammed. Okay. Okay, Daro. Yes, that is the answer. Expecting reply from everyone. Yes, Ruchir. Great. Yes, Hemant. Ram, Sandeep. Yeah, what do you mean by streaming data? If you have no idea, just give me no idea. Just that's it. Not enough. More than enough. I will explain. Okay, great. Yeah, I got the. Yeah, great. Thank you, Ram. Yeah. Thank you, Hemant. Thanks for the response. Thank you, everyone. Live data. Yes, great. So the meaning of streaming data is the name clearly indicates streaming. That means like continuously generating data. Continuously generating data. What do you mean by continuously generating data? Like as the first example, like a live streaming, like live data. Live data. Just I'm giving a simple example. Like yeah, take one shopping mall. And when you do some shopping, there each floor there are different floors is there. Each floor some CC cameras are there. Each floor CC cameras are there. Those CC cameras, for example, yes, keep on capturing the data. Keep on capturing the data. That data I need to copy to Hadoop. How can I? Yes, streaming data will take care. That is the meaning of streaming data. That streaming data we are copying into Hadoop by using Flume. By using Flume, we are importing the data. Yes. Not only streaming data. Yes. Not only yes. The CC cameras data, like continuously generating log files is there. Keep on capturing the data. Continuously generating log files, audio files, YouTube data. Video files. Take the Twitter best example. Yes, I want to know the reviews of the particular iPhone from different countries. Yes, who are giving the reviews? I need those information. Yes, those data by using Flume we are going to import. I will give the example of Flume Twitter Analytics. By using Flume, I get more clarity. So now the difference between Flume and Scoop is Scoop have connectivity only for structured data. Scoop have connectivity only for structured data. Flume have connectivity only for streaming data. Streaming data. So these both are transporter ecosystems. Okay. Is it possible by using Flume to connecting to RDBMS? No, not possible. Flume only possible for connecting streaming servers. Okay. The next question is it possible by using Scoop we are connecting to the streaming servers? No, not possible. Right? The question is here. Scoop have connectivity only for RDBMS servers only, warehouse servers only. Okay, and Flume have connectivity only for streaming data. I get one question from there. Yes, the question is streaming data that can be classified under unstructured data. Yes, of course. We can consider it as unstructured data also. Okay, there are different type of log files we are importing by using Flume. Yes, that log files is a unstructured data. Video files we are importing, audio files. That is called unstructured data only. Okay, how it is possible, Krishna? How to analyze those data? How to import? In practical classes, I will explain you. In regular classes, practicals, that time I will give you the examples. All this Flume, Scoop, everything. I will give you the example so that you get the more clarity. Let's move to the next one. Woozy, one more ecosystem. So as a developer, these all are our responsibilities. What is Woozy? Yes, Woozy is a scheduler. Before Woozy, I'm getting one more question regarding Flume. With the Flume, there is a just import only, right? Exactly. By using Flume also, just we are going to import the data. Even by using Scoop also, just we are importing the data. That's it. We are not doing any analytics by using Flume or Scoop. These two just transporters. That's it. No, yes, and only transporters only. And by using Scoop, you are going to perform importing and exporting operations. By using Flume, just we are importing. That's it. There is no export concept in Flume. Okay, and one more question. So what is the meaning? Daro, yeah, wait for some time. There are different data source systems is there. Okay, we have the data source. Hadoop have capability to store structured data, unstructured data, semi-structured data. There are different data source systems is there. Wait for some time, you get the clarity. What are the data sources? Now let's move into the next one. Woozy. What is Woozy? It's like a scheduler. By using Woozy, we are going to schedule the jobs. We are going to define the workflows. We are going to define the workflows. What do you mean by scheduler? What do you mean by scheduler? What do you mean by workflow? Yes. For example, I have some jobs is there. Every day, I need to import the data. Every day, I need to analyze the data. Is it clear? My voice is clear? Okay. Okay, yes. My requirement is every day I need to submit my queries. For example, I have some queries is there. Some data is there in warehouse, RDBMS. Some data is there like a streaming server. I need to import the data. After importing completed, I need to apply the queries like a Hive, Pig. I need to process the data. So the question is, I don't want to submit manual work. I don't want to submit manual work. I need a workflow is required. Once a scoop completed, next automatically Hive want to be trigger. Once Hive completed, Pig want to be trigger. That is my requirement. We're submitting manually in the real time. First we're submitting scoop. After scoop completed, we're submitting Hive. Once Hive completed, we're submitting Pig. We're doing manually? No, not required. You can schedule a one workflow. You can schedule a workflow. So the workflow will be taken care. Once the importing completed, scoop completed, automatically Hive started. And I'm telling, once Hive completed, then immediately start scoop, Pig. Once Pig completed, again start Hive, scoop. I'm telling. What are the order I'm telling? According to the order, Woozy executing the jobs. That is called workflow. And also Woozy is a scheduler also. That means like for example, every day at 8 a.m. I need to submit my jobs. How we are going to do it? We are doing manually? No, we are not doing manually. We are going to schedule it. This is scheduler. Once if you schedule it, automatically every day the job is executed. The job will be triggered accordingly. Okay. By using those responsibilities, we are calling like a yes. By using those scheduling responsibility, we are calling as a Woozy. Yeah, friends, I have a couple of friends knows like a schedulers, other schedulers. Every language, every technology, they are using different schedulers. In Hadoop, we are using schedule called Woozy. What are the schedules are available in other technologies? Any idea? The question is, what are the schedulers are available? There are different schedulers are there in different technologies.
Control M,
Good
Java
example.
batch.
Yes, that is a good example. Control M, one of the best example. A scheduler.
You have Java Spring Batch.
Okay, Java Spring Boot. Okay, fine. And also Artosys.
You have cron jobs.
Cron jobs schedule Artosys. Okay, cron jobs. There are different examples here. Different technology, we are using different schedulers. Now in Hadoop, we are using Woozy. Okay, that's more than enough. And regular classes, I will give you example how to schedule the jobs, what concept is there internally, those concepts. But today, just high level. Can we consider trigger as a kind of scheduler? Kind of scheduler, okay, but exactly not a scheduler. Trigger is different, schedule is different. Okay. Hopefully, it's clear the terminology. Okay, just high level, more than enough. If you go for a in detail practical, that time you get more clarity, like how exactly you get the answers to those points. Now move to the next one, Zookeeper. Yes, one more ecosystem in Hadoop. Yeah, by using Zookeeper, we are going to maintain the data logs, data log concepts. We are going to store the records, failure of the records, and controlling the data logs. That type of configurations, we are going to do it in